Hello, welcome to More Chemistry. I'm Dave Hicks, and today we're going to talk about molarity calculations. When I finish this video, I would hope that you'll be able to use the molarity as a way to express the concentration of something. Here I'm not referring to concentration like thinking real hard. However, we may have to think kind of hard when we do this. But here I'm talking about how much stuff is in there. So we're going to see this new unit of expressing how much is in there that we call molarity. You're going to have to calculate between the moles and the grams of something, how many liters it's in, and calculate molarity itself. We have a formula for that I'll show you. And finally, we should be able to use dilutions to calculate our concentrations as well when we dilute things. Okay, so as I said, molarity is a way that we express the concentration, how much stuff is in there. You maybe have seen this word concentration with things like this is an all new concentrated product. That just means that it has more in there. Let's say if it was a soap and it's a really concentrated soap, it means there's more soap molecules in there per some given volume. So if the volume is one container or one jar of soap and it was more concentrated, it would have more soap molecules in that jar compared to the same size jar of a less concentrated or the regular strength. Molarity has a definition. We take the moles per liter. I bet you could see that in the word molarity. There's going to have something to do with moles, right? So it is the moles of the solute, the stuff that's being dissolved, divided by the liters of the entire solution, how much volume or how much space it takes up. Now we use some words that are similar to each other. We might talk in molarity. What is the molarity of this solution? When we talk about the solution, we might say this is a 6 molar solution. So instead of calling it 6 molarity, we just shorten it up, say molar. And we use a big capital M to represent it. And like I said, it's moles per liter. That is the definition of it. So all of these are the same thing. Molarity, molar, big capital M, and moles per liter. All that's the same. Here you can see our formula that we have for it. And molarity is equal to moles over liters. You're going to see me use that in a couple of examples for you. Some of the additional skills you might have to have, though, is many times instead of working in liters, which is our definition, sometimes we'll be working in milliliters instead. And so I'm going to show you how to convert things between milliliters and liters. You just have to move your decimal 3 places to the left, or if you're changing it to milliliters, 3 places to the right. And then down here, we have to sometimes be able to convert between moles and grams. If you don't know how to do that, how to get something from grams into moles, you may want to jump back into my series that I have here on chemistry and find the one where I convert grams and moles to each other. Okay, well, let's take a look at an example. So the different types of molarity problems that we have, they come in different flavors, I guess you could say. Sometimes they might want us to know how many grams do we need to add, grams of our solute. Let's say we're making up a saltwater solution or something. They'd want to know how many grams of salt do I need to add to this in order to make a certain concentration. So we'll have to figure out how to do that. Sometimes they want to know what volume do we need to make this solution in order to have a certain concentration. And then other times, maybe they just want to know what is the concentration of the solution. So there are 3 basic types of problems that we're going to take a look at today. And for each of those 3, they basically have 3 steps that go with them. One step that you may have to do is you may have to convert between moles and grams, as I said earlier. So that might be one thing that you're going to see that's in common with these. Another step that we might have to do is we may have to change milliliters and liters back and forth. And finally, the one thing that you'll see every time is that we're going to be using the molarity equation and setting that up, moles over liters, and that way we can do that to get the molarity of something. All right, that's the relationship that it has. So, first example here, what I want to do is you're going to see that these are all pretty much the same. So what I'm going to do is set up some examples right in front of you, and then I'll solve them. So over here, let's talk about, let's say if I want to solve for molarity first. So here's my question mark. What molarity of a solution contains, let's just say 10 grams, and let's make it a base. How about sodium hydroxide? And let's put that in 250 milliliters of solution. So there's my first example. What's the molarity of a solution that contains 10 grams sodium hydroxide per 250 milliliters of a solution? Now, we know we're looking for molarity, so I'm going to put my big capital M here, looking for that. And I know that it's moles of the solute divided by the liters of solution. So there's the things that I'm looking for. And so I need information about the solute to go on top. And many times when we talk about molarity, we refer to the solute, even though that it's not the majority of the solution. So in this case, sodium hydroxide is our solute, and we need to show that's what we're going to need to convert and stick in here for the moles, because the sodium hydroxide, what solid or what substance gets listed here is usually the solute, and we need to figure that out. In this case, I've been given that I have 10 grams of sodium hydroxide. It's in grams. And I told you that one thing that's very common is you're going to have to change grams into moles in order to use it in this equation, right? So I'm going to do that first. I'm going to change the 10 grams into moles. So I want to know how many moles of sodium hydroxide is equal to 10 grams of sodium hydroxide. So I'm going to set up my dimensional analysis here. On the bottom is going to go grams. And if I look that up on the periodic table, I see that's 40 grams, and that's in 1 mole, because that's my molar mass. And if I crunch that out, I get 0.25 moles of sodium hydroxide. Okay? So now that I have the number of moles, now I can take and put that in right here for the number of moles that's in my solution. So I'm going to do that, 0.25 moles of sodium hydroxide. And underneath, I want the liters of solution. Well, I have 250 milliliters of solution. I need to change it to liters. Well, there's a saying that I say in my class, to change something from milliliters to liters, you need to move it 3 places to the left. The decimal I'm referring to, move the decimal 3 places to the left. To kind of help you remember this a little bit, the L there for liters, that might help you remember that it's left. And if you take a look at next to it here, you have milliliters, right? 1, 2, 3. That's on the left-hand side of it. So that kind of helps to me to remember that I need to move it 1, 2, 3 places to the left, that decimal. I'm using the M as kind of my thing to help me remember. 1, 2, 3 places to the left. Huh? I don't know. I like to think of little goofy things like that to help me remember. So I'll do that down here. Here's my 250 milliliters. And my decimal's right here at the moment. So I'm going to take it and move it 1, 2, 3 places to the left. And it's going to end up right there, 0.250 liters. Now, you may have other ways that you remember or know how to change things from milliliters to liters. You know, maybe you do King Henry died Monday or something like that. That's fine with me. Use whichever way you'd like. That's just my little mnemonic way of remembering how to get from milliliters to liters. Because in chemistry, it seems like we do that quite often. Okay, so now I have 0.250 moles of my solute, the sodium hydroxide, in 250 50 milliliters or 0.250 liters. And crunching that out, I'm going to get just 1 molar, right? So 1 molar, we would write 1 molar of sodium hydroxide. Again, notice how we talk about the sodium hydroxide. That's because that's what's dissolved inside of the solution. So the molarity goes with the solute itself. How many moles of sodium hydroxide I have in here. Okay, how is that? Not bad for your first molarity problem. I told you might have to concentrate a little for this. All right, maybe that wasn't such a good joke after all. Anyways, I'm going to clear this off and let's try another one. So this time, let's say that I already know my molarity of my solution, or at least I know my target molarity that I want it to be. Let's say I want it to be a 6 molar solution. But this time I want to know how many grams of, we'll take a different substance. How about some sodium chloride? Make things easy on us. And let's change the volume here. Let's make it 500 milliliters this time. So, if I wanted a 6 molar solution, how many grams of sodium chloride would I have to dissolve per 500 milliliters of that solution? Well, again, I'm going to work with my molarity formula. And, whoops, there we go. I'm going to work with my molarity formula. And I know that this is a 6 molar solution, so I'm going to write that right in there. And that's equal to, I don't know how many moles of solute. That's kind of what I'm looking for, isn't it? I want the grams. How am I going to get the grams except to take my moles and then change it into grams? So this is on the top here is where my information goes for what I'm solving for, right? And then liters of solution down on the bottom. Again, 3 places to the left. So this is going to be 0.500 liters. And I need to solve for the moles here, that X, that's what I need to do. And now I know that sometimes people's math skills make it so that, geez, it's a fraction. You don't know how to deal with it because it's a fraction. Man, I hated fractions in school too. But then I had a good teacher friend of mine, math teacher, show me that all you have to do is just take this thing and put a line there and a 1 there. Now I can just cross multiply and divide and get my answer. And most people are pretty good at that. I'm pretty good at solving cross multiplication like that too. So when I do that, I find out that X here, the number of moles, is equal to 0.5 times 6, that is 3. So it's equal to 3 moles of my sodium chloride. Now I have to do that next part because I'm not done yet. I need to get it to grams, so I'm going to have to change my moles into grams, right? So here I am with my question. My question is, how many grams then of the sodium chloride is equal to 3 moles of sodium chloride? So here I go. Down on the bottom this time I'm going to put the mole because I want that to cancel. And on the top I'm going to look up its molar mass, which is 58.5. That's grams. And when I crunch this one out on my calculator, I get about 176, 180 grams, something like that. I'm going to write in here 176. Whoops. All right. So in this case, I went and I knew the molarity of my solution. I wanted to find out how many grams. So first I calculated the number of moles, and then I changed it into grams. All right, let's try one more. And one last variation that they have on this is sometimes they will want to know what volume do we need to make this solution. So let's change things a little bit. Let's say this time that I have a 3 molar solution. And this 3 molar solution, we want to contain 100 grams of, let's make it calcium chloride. And we want to know how many milliliters of water do I need to add so that this 100 grams of calcium chloride makes a 3 molar solution. Again, starting out with my molarity formula here. And I know that it's 3 molar. So a 3 molar solution of this calcium chloride is equal to, well, I don't know how many milliliters, but my formula down here has to be in liters, right? So I'll put liters there, and that's what I'm looking for. I'm going to put my X there. And then I have 100 grams of calcium chloride. Now, I don't know, that I'm looking for moles, right? I got to have moles on the top. So I see that I'm going to have to change my grams into moles in order to get there, huh? So here we go. I want to know how many moles is equal to 100 grams of calcium chloride. So I will do my dimensional analysis. And on the top of this, I will put moles, because that's what I'm trying to change it into. And on the bottom, I'm going to put its molar mass. And when I look this up, I believe I get 111, huh? 111 grams of calcium chloride is equal to 1 mole. And when I put this into my calculator, I get pretty close to 0.9 moles. Now that I have the calcium chloride, the solute in moles, now I can throw it into my formula. And again, I'm going to do that trick, cross multiply and divide here. So I'm going to get, what, 3x is equal to 0.9. And when I crunch this out, I'm going to get that x is equal to 0.30. 0.30 what? Liters. You see that? It's in liters. What do I want? Milliliters. So let's see. I went 3 places to the left to get my milliliters into liters. So guess what I'm going to have to do to get it back to milliliters? Yep, you got it. 3 places to the right, huh? So let's do that. I'm going to move this 3 places to the right. So I'm going to move down here so I got a little more space. 0.30 is going to have to move 3 places to the right. 1, 2, 3. It's my new location, and I'm going to have to fill in a 0 there, huh? Because I moved it 3 places that way. Again, if you have another way of doing that, then that's fine. The answer here then, 300 milliliters. There's my answer for this thing. All right, so quick review. Today we talked about molarity as being a way that we express concentration. It tells us how many moles of solute is contained per liter of solution. How much stuff's in there? That's what we want to know. And we've seen that we've set this up, moles divided by liters, and there are a couple of extra things that you have to do. Sometimes you have to change things from grams to moles or moles to grams. And sometimes we have to convert between milliliters and liters. But in the end, we just put it inside that molarity formula, moles over liters, and do our mathematics to it. And we're able to find either how much stuff, how much solute, how many grams of solute, what volume it needs to be, or maybe just what the molarity is itself. All right, so that's it for me with molarity. I think I have another one of these coming up in the series where I show you dilutions. If you need to learn that, you can check that video out. Otherwise, have a great time, have fun with your chemistry, and we'll see you next time.